This is the screencast for section 6.4, example 3. We're going to look at converting coordinates from polar to rectangular. So making the connection between what would the function graph look like as opposed to what would the polar graph already looks like. Well, if I look at a little simulation here, we've frozen a polar graph, and this point here is r comma theta, which if you put it on the xy plane is really x comma y. And we can see that the x coordinate is going to be involved in the cosine of theta from our polar coordinate. So the cosine of theta is the adjacent over hypotenuse, so x over r. So the x coordinate of the rectangular coordinate would be r times the cosine of theta. So in your function mode or your xy plane, the x coordinate would be r times the cosine of theta. And then similarly, the y coordinate would be r times the sine of theta, which should sound familiar at this point. So example 3 gives us a chance to practice those. We're going to find the rectangular coordinates of the points with the given polar coordinates. So if our polar coordinate is 3 comma 5 pi over 6, our r value is 3, radius, and then 5 pi over 6 is our theta. So the x coordinate is going to be 3 times the cosine of 5 pi over 6, and yes, by all means I would expect you to do this without a calculator. So that's going to be 3 times negative square root 3 over 2, which is negative 3 square root 3 over 2. Then the y coordinate would be 3 times the sine of 5 pi over 6, so that would be 3 times 1/2, which is 3/2. So overall, our rectangular coordinates, because we need to put these in parentheses as if we were graphing this point, would be negative 3 square root 3 over 2, comma 3/2. And yes, we would need our calculator to kind of figure out what this value specifically is, but it does look like a good estimate of where we would go if we were plotting negative 3 square root 3 and then comma 1.5. Part B, since our angle is in degrees and we don't really know from the unit circle what the cosine or sine of negative 200 degrees is, this one I would definitely allow you to use your calculator on. The x-coordinate is 2 times the cosine of negative 200 degrees, which using my calculator is about negative 1.88. Then the y-coordinate is 2 times the sine of negative 200 degrees, which is about 0.68. So overall, that point would be negative 1.88 comma 0.68 if I were just plotting this in function mode on an xy plane, and that looks about right. A little less than negative 2, and then a little more than negative 2, and then 0.68. The now try problem number 15 is also something I would expect you to do without your calculator, since we do know by our vast knowledge of the unit circle what the sine and cosine of 7 pi over 3 is. The x-coordinate of this polar point would be 1.5 times the cosine of 7 pi over 3, which is going to be 3/2 times 1/2, so 3/4. Then the y-coordinate is going to be 1.5 times the sine of 7 pi over 3 again. That's going to be 3/2 times square root 3 over 2. So that's about 3 square root 3 over 4. So the xy coordinates of this polar point converted to rectangular coordinates is going to be 3/4 comma 3 square root 3 over 4.